Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to another edition of the online class. If you remember, in our last class, we talked about the periodicity of elements, where we discussed the families of elements, the periodic property of these elements, the first transition series and their property. We also talked about the lanthanide and the actinide. Today, we are going to be looking at types of reactions. Types of reactions, where we are going to look at definition of these types of reaction and examples. The first one we are going to look at is the combination reaction, which is also known as the addition reaction. This type of reaction occurs when two or more elements combine to form a single compound. For example, when we have zinc, when zinc reacts with sulfur, it produces zinc oxide. Another type of example is when iron filings. When iron filings react with powdered sulfur, when these two elements are heated, they produce a gray solid of iron sulfide. So that is an example of a combination reaction. And like we have said, it normally occurs between two or more elements. So it can occur between two elements or more than two. The next one we are going to be looking at is thermal decomposition reaction. From the word thermal, decomposition means breakdown. Thermal, that means we are using heat. Decomposition with the aid of heat. Now this occurs when a compound splits into two or more substances using heat. Now, if you look at example, this is an example here. Here, mercury oxide decomposed to give us mercury, and then oxygen gas is evolved. Another type is the thermal decomposition of lead 2 triazonitrate 5. Let me show you very well so that you can see it. Lead 2 triazonitrate 5, which decomposes to give us lead oxide, nitrogen 4 oxide, and then oxygen gas. That is another example. Now, usually in thermal decomposition reaction, at least one of the products is a gas, while the other can either be a liquid or a solid, which is called a residue. And it is the opposite of combination reaction, because here we decompose the compound, while in combination reaction they come together to form a particular compound. Now, let's look at another type of reaction, which is displacement reaction. Yes, from the word displacement, or we can say replacement reaction. That means one particular element is replacing another one, especially those ones that are more electropositive. They displace those ones that are less electropositive in a compound. So this reaction occurs when an element which is more electropositive displaces another one which is less electropositive in a compound. For example, look at this example. The reaction between zinc and copper sulfate, copper 2 tetraoxosulfate C, where zinc displaces copper from the copper 2 sulfate, forming zinc tetraoxosulfate C, and then copper is being displaced. Now, in this displacement reaction, if you look at the activity series, the way they are arranged is that the elements, those elements at the top of the series are more electropositive than those ones at the bottom of the series. And because zinc is above copper, that is why zinc is able to displace copper in the solution. Now, another example, let's look at the reaction of magnesium ribbon and then dilute HCl. You will see that at the end of the day, it forms magnesium chloride and then hydrogen gas is being evolved. Why? Because hydrogen is lower than magnesium in the activity series. So magnesium is able to displace hydrogen. Now, if you look at those elements below hydrogen in the series, they cannot displace hydrogen except those one above hydrogen in the series. So that is that for that. And if you even look at the halogens, you see, fluorine will displace chlorine, and then it goes like that, because those one at the top, they will displace those elements at the bottom, as you go down the group, I mean the halogen group. For example, now let's look at the reaction between bromine and potassium iodide. You see, bromine to form potassium bromide, and then iodine is being liberated. This is because bromine is what? Is higher in the group, so it's able to displace iodine, which is lower than bromine in the group. So that is that. Now let's go to another one, which is the thermal dissociation. Now, in this thermal dissociation is a type of reversible reaction in which only a temperature change determines the direction of this reaction. In this type of reaction, each molecule of this substance dissociates into two or more simple molecules. Now, for example, let's look at this. This is the thermal dissociation of ammonium chloride, where ammonium chloride is being dissociated to form ammonia gas and then HCl gas. Now, this is a reversible reaction where the forward reaction will be in the presence of heat, and then the backward reaction, that is the recombination of ammonia gas and HCl, will be at what? When it is cold. When it is cold. Another example is that of the reaction between nitrogen and then hydrogen to give us ammonia. It is also a reversible reaction where only temperature and pressure determines the direction of this reaction. Now let's continue. The next one we are going to be looking at is the reversible reaction. In reversible reaction, it is a type of reaction that goes either way, like I said, depending on the reaction condition. That means depending on the temperature and the pressure of that reaction. Now, let's look at, for example, let's look at this. The first reaction there, which is the reaction where water is being changed to gas. That is, when you heat water, then it changes to vapor. So water in form of a gas is called vapor. Now, if you look at this particular reaction, the forward reaction, that is in the presence of heat, then the water will change to vapor, that means by boiling. And then when you cool it down, it changes back to liquid. Let me repeat myself. When you boil this water, that means when you apply heat, the liquid water changes to vapor, and then when the vapor is cooled down, it changes to what? To liquid back. Now, at equilibrium means when both forward and backward reaction occur at the same rate. Now, both the reactant and the product will be in the system at that particular time. Both of them will be in the system at that particular time. Now, the second one, which I've already explained before, is the decomposition of ammonium chloride to give us ammonia and then hydrogen chloride gas. The forward reaction is in the presence of heat. You have to heat the ammonium chloride to form decompose to ammonia and then HCl gas. Now, if you cool it back, these gases recombine together to form ammonium chloride back. Now, this type of reaction can only be reversible, since they are gases, when they are in what? When they are in a closed system. That means none of the reactants or the products can escape. So they can recombine together to form back the reactant when it is cooled. So that is that on that. The next one we are going to be looking at is the double decomposition reaction. This double decomposition reaction, it occurs when two or more compounds decomposes to form a new substance by an exchange of ion or radical. Now, we have this type of reaction, we have 4 types. We know what is ion and what is a radical. We have 4 types. This type of reaction is 4. That is, we have 4 types of decomposition reaction. One of them is the precipitation reaction. You have seen that one before. I've shown you before the reaction between silver nitrate, silver triazonitrate 5, and then sodium chloride. Now, this reaction, the precipitation reaction, is a reaction between 2 aqueous solutions to produce one insoluble compound and one soluble compound. If you look at this reaction, you see the reaction between the silver nitrate and sodium chloride to form silver chloride and then sodium triazonitrate 5. The silver chloride, sorry, this is a typography error. The silver chloride is solid, is a white solid in color. Is a white solid in color. Now, let's look at another type. That is, neutralization reaction is also a double decomposition reaction, in which HCl is reacting with sodium hydroxide to form sodium chloride and water. If you look, there is exchange of ions there. Another one is the formation of volatile acid, which occur when a mixture of less volatile acid and a sort of more volatile acid is heated to produce a more volatile acid. We look at the reaction there, the reaction between sodium chloride and H2SO4. H2SO4 is less volatile, so it produces sodium tetraoxosulfate C and then hydrogen chloride gas, which is more volatile. That is that. And the last one, which is the libration of ammonia gas. That is when a mixture of ammonium salt and an alkali is heated, ammonia gas is evolved. This is a test we use in the this is a test for ammonium compound, where we heat them with sodium hydroxide to produce ammonia gas. Now, the last one that we are going to be looking at today, or let me say the second to the last one that we are going to be looking at today, is the catalytic reaction. That means catalyzed reaction. This type of reaction is aided by a catalyst. That means it takes place in the presence of a catalyst. If you look at this particular reaction now, the decomposition of potassium triazochlorate 5 in the presence of manganese 4 oxide as a catalyst, which produces potassium chloride and then oxygen gas being given off. Now, what is a catalyst? A catalyst is a substance which alters the rate of chemical reaction, but itself remains unchanged at the end of the reaction. Now, types of catalysts. We have the natural catalyst and the artificial catalyst. Now, example of natural catalyst. The natural catalyst example are sunlight and enzymes. We have some reactions that proceed in the presence of light. Those type of reaction, we call them photochemical reaction. We call them photochemical reaction. For example, when a mixture of hydrogen gas and chlorine gas is react together. Now, this type of reaction takes place in the presence of sunlight to produce hydrogen chloride gas. Also, another reaction is the decomposition of isochlorate 1 acid, which takes place in the presence of also sunlight to produce hydrochloric acid, and then oxygen gas is being given off. Now, the type of reaction that proceeds using enzymes, that is enzymes, we have these organic reactions. Most of them proceed in the presence of enzymes. Now, what are enzymes? Enzymes are complex organic compound that is proteinous. We have some reactions, organic reactions, most especially that is aided by an enzyme. For example, in the fermentation of sugar, the enzymes that act on sugar are the invertase and the Rxns. These are the two enzymes that act on sucrose during the fermentation of sugar. Now, types of catalyzed reaction. Mainly, we have two types of catalyzed reaction. We have two types of catalyzed reaction. That is the homogeneous catalysis and the heterogeneous catalysis. Now, the homogeneous catalysis reaction is a type of reaction that the catalyst, the reactant, and the product are all in the same phase. That means it's either all of them are solid or all of them are gases. Now, another type of example is the heterogeneous catalysis. In this type of catalysis reaction, the catalyst, the reactant, and the product are in different phase. Now, look at the examples I've given below. Here is under homogeneous catalyst. If you look at it, both the reactants, the catalyst, and the product are all gases. Now, if you look at the heterogeneous catalysis, the reactants, they are gases. The catalyst is a solid, while the product is also a gas. So they are in different phase. So that is that on catalytic reaction. The next one we are going to look at is the oxidation and reduction reactions. That means which is due to the either the donation or the acceptance or the donation of electron, which we are going to look at in our next class in details. So this is our assignment. As our assignment, state the characteristics of a catalyst. The second one is that state the types of reaction below. That is our assignment. So until we meet in another edition of this online class, before that, I will advise you to go and look at oxidation and reduction reaction. We have different definitions for them. So this is where we are going to stop today. Assalamu alaikum wa rahmatullahi wa barakatuh.